All right, we're still dividing polynomials by factoring, only now we have a new factoring technique called pi and sigma. So remember that factoring techniques are just techniques. They're not algebra. Algebra is just factor the quadratic or factor the polynomial. But these techniques, the names indicate to you exactly what you're about to do and on what kind of polynomial you're going to use them. So pi and sigma works on a quadratic trinomial. So I bet you're saying, what the heck is a quadratic trinomial? I'm going to tell you. A quadratic trinomial is a trinomial that can be written this way. X squared plus some number b times x plus c. So in this case, b and c would be numbers, numerals, probably integers, but the whole thing together is one number. Quadratic just stands for a second degree polynomial. We call those quadratics. And a trinomial, obviously, because you have 1, 2, 3 terms. Quadratic trinomial. So I'm going to give you an example of one with actual numbers in it. X squared plus 7x plus 10. So you can see that this is definitely a quadratic trinomial. X squared plus 7x plus 10. And it's exactly the form that I've written here, x squared plus bx plus c. That's a form. When you see a trinomial like that, you want to think to yourself, oh, I need to use pi and sigma method. So pi and sigma method refers to a practice of figuring out two numbers that can multiply to give you this number 10, which is in the C position, and the same two numbers that add to give you 7. So multiply is product. We use the Greek letter pi. It's a capital pi, not the 3.14 pi. The Greek letter pi stands for product, and you're going to use whatever number is in place of C. So you want two numbers that multiply to give you whatever C is, and then the same two numbers you want to add, and this is a Greek capital S that stands for sum. So sigma is this letter, it stands for sum, and pi stands for product. I don't know. I was taught with these letters, so these are the ones I use. And sigma has to equal b. So the same two numbers have to multiply to give you C, but add to give you B. Well, 10 is C, so two numbers that will multiply to give me C are 5 and 2. 5 times 2 is 10, but the same two numbers add 5 plus 2 to give you 7. Pretty cool, huh? So I'm going to erase something. Well, I'm not going to. I'll do it on the next example. So what would those two numbers be? They'd be 5 and 2. Once you have those two numbers, you actually have the factors already. X plus 5, because it's a positive 5, times x plus 2. I have now factored that polynomial. You want me to prove it? You should say yes, because this is algebra. You should make me prove it. Let's multiply. Let's check it by multiplying that number back in. I'm going to put this on this side this time, just because of room. All right, so I'm going to take x plus 5, and I'm going to multiply it to x plus 2. And if I've properly factored this polynomial, then when I multiply the two factors, I should get back to the polynomial. So x times x is x squared. Ooh, good start. X times 2 is plus 2x. That doesn't look right. But x times 5 is plus 5x. And then 5 times 2 is plus 10. So I can combine these two like terms, x squared plus 7x plus 10, and that's exactly where I started, so I know that these are indeed the factors of that polynomial. So I bet you're thinking, that looks good, that seems easy, but I don't think there's any way I could ever do that on my own. Well, let's fix that. The only way to fix that is to do a bunch of examples, so let's do one. Let's factor x squared minus 2x minus 3. So it's a trinomial because there are 3 terms. It's a second degree trinomial, which means it's quadratic. That means I can factor it using pi and sigma. So pi means I want the product, I want 2 numbers that multiply to give me -3. Right? 2 numbers that multiply to give me -3, and I want the same 2 numbers to add and give me -2. Okay, well, what do we think? 3 and 1 surely give me -3, and then 3 and 1 can certainly combine to give me a -2, but what order? So I'm going to put a 3 and a 1 here, because a 3 times 1 would give me 3, and a 3 and a 1 here, and then I have to use this -2 to decide which one's negative. Well, -3 plus 1 would be -2, and then if I put -3 times 1, I'd get -3. I've used pi and sigma now to find my 2 numbers, and I want you to write this little y. We're going to use it in the next method for factoring quadratics, and it'll be a little complication on the whole quadratic trinomial thing. And so I want to set you up working this way because I want you to use this in a minute. So -3 and a +1. You've done factoring it because all you have to do is put the x in front. Factored. Let's check it to be sure I actually have the right factors. X minus 3 times x plus 1. If I distribute, x times x is x squared. X times 1 is 1x. -3 times x minus 3x's. And -3 times 1 is -3. X squared, 1x, take away 3x's is -2x minus 3. And that's exactly where I started, so I know that this is how I factor, or this is the prime factorization of this number. Let's do another one. Okay, let's factor x squared minus 6x, sorry, typo, minus 5x minus, there's the 6. Okay, we want to factor this. We're going to use pi and sigma method because I'm looking at a quadratic trinomial. And so I need 2 numbers that multiply to give me -6, but add to give me -5. And that would be -6 and a +1. So notice I did it without the pi and sigma part. Pi and sigma is just a helper tool. If you need it, you need it. And if you don't, you don't. No big deal. Pi is -6. Remember, pi is whatever c is in your trinomial, -6. And sigma is whatever b is in your trinomial, -5. And then you set up 2 numbers that multiply to give you -6. Same 2 numbers have to add to give you -5. -6 and 1, -6 plus 1. It works out, so I choose -6 and 1. If you don't need to write pi and sigma, don't. It's a helper step just to get you started. Once you can see those numbers, use them. The factors are x minus 6 and x plus 1. Let's check it. X minus 6 times x plus 1. X times x, x squared. X times 1 plus 1x. -6 times x minus 6x. -6 times 1 minus 6. X squared minus 5x minus 6. I ended up right back where I started, so I know I factored properly. All right, so you're going to get a lot of chances to practice factoring quadratics using the pi and sigma method. But remember, the whole point is so that we can do division by factoring. So let's do a division problem. Let's divide x squared plus 9x plus 14. And we're going to divide it by x plus 7. So if x plus 7 is a factor of x squared plus 9x plus 14, I should be able to factor the numerator, cancel with the denominator, and I know what the answer is. If it's not a factor, I would have to do long division in order to factor this or do this division. But I'm hoping for the factoring. Now, this is a place where you have to be really careful about how you work, because remember, pi and sigma is a method. It's not algebra. It's a method for factoring. If you're able to see just by looking that this is x plus 2 times x plus 7, if you're able to see that, then you should just write it down, because that's what the algebra is. If you're able to see that, then you should just write it down. That's algebra. If you're not, you need to take it off to the side for scratch work, and you need to do the method on it. X squared plus 9x plus 14. So just this I'm trying to factor. What numbers can I multiply to get 14 but add to get 9? Well, I'm not sure, but a way to find it, that's why I chose a problem like this, is you can start with the numbers that you're going to multiply and just start writing all the factor pairs of 14. Well, the simplest one is 1 times 14 equals 14, correct? Can you add or subtract with 14 and 1 to get 9? No. So the next one would be 2 times 7. Can you add or subtract with 2 and 7 to get 9? Sure, 2 plus 7, that one's done. 7 and 2, so x plus 7 and x plus 2 would be the factors. Look what I have here. I have them in the opposite order, but they're multiplied. Doesn't matter what direction you multiply. And so that's the factored problem. Cancel this, and the answer is x plus 2. So I want you to be really careful when you work. I want you to be careful about what the algebra is and what is only a method for doing your algebra. The method goes off to the side or on a piece of scratch paper. It doesn't really matter to me unless I ask you to show me the method so that I know you know what you're doing. I just want you to factor the problem. All right, so let's do one more. Let's do x squared minus 6x minus 72, and I'm going to divide this by x plus 6. If x plus 6 is a factor of this polynomial, then x plus 6 will be one of the factors of the numerator, and I'll be able to cancel with it. So first thing, I could, if I were able to just guess and check and put my factors in the numerator, x plus 6, and go from there, I would do that. But I can't. I need to go over to the side, use a caret. That's how this little thing is how I say I'm going to go to the side. And I'm going to write the problem again. X squared minus 6x minus 72. Two numbers that multiply to give me negative 72, but add to give me negative 6. What? First off, I'm not quite sure what I'm doing here. So let's do pi equals negative 72 and sigma equals negative 6. So I want two numbers that multiply to give me 72, and the same two numbers have to add to give me negative 6. I'm not really sure what those are, but luckily I alluded here to a little trick. Let's start with the multiples. Let's do 72. We don't care about the sign. Let's take 1 times 72. Can I combine 1 times 72 to get 6? Of course not. So I'm going to have to keep working. So another factor pair, the next one up on the left-hand side. 2 times 36 gives me 72. Can I add or subtract with 36 and 2 to get negative 6? Of course not. So the next would be 3. Can I divide 72 by 3? Well, I can. 3 times 2 is 6, carry the 1, 24. 24 times 3 equals 72. I still can't combine 3 times 24 to get negative 6. From here it gets easier. I don't have to keep doing arithmetic in my head because I can use the fact that if I multiply 2 by 2, I get 4. So if I divide 36 by 2, I get the factor pair 4 times 18. 4 and 18 don't combine. Let's look at the next one, 5. It definitely doesn't divide by 5. So 3. I'm going to multiply 3 times 2 to get 6, and then divide 24 to get a 12. 6 and 12 definitely arranged to give me 6. Let's try it out. If I put 6 here and 12 here, 6 here and 12 here, all I have to do is arrange the sign to see if I can get negatives. Well, -6 would be 6 plus -12, and then -12 times 6 would be -72. So I know that I'm looking at a -12 and a +6. Those are my factors. Or these are my solutions, actually, which doesn't make sense to you yet. But my factors then would just be a matter of putting the variable in front. X minus 12 times x plus 6. These factors are the same. They cancel. And so my answer then is x minus 12. Okay, that's a lot. I know it's 15 minutes of your time already spent, but I'm guessing the right move right here, right now, is for you to go back to the beginning and start the video again and follow along again. I covered a lot. None of it is all that hard, but it's just a lot of new stuff in one small group of time. So I would go back through if I were you, and I would watch the video again. Your choice, though. Whether you do or not, the important thing to notice is that pi and sigma method is a method for factoring quadratic trinomials, and factoring, or the pi and sigma method, is just a method. It's not actually the algebra. The algebra is converting this quadratic trinomial into factored form. So when you write your problems out, you want to make sure that you're really careful only to put the algebraic steps in your algebra, and if you want to work off on the side, then you can do that to show the method you use to get there.